So today we're gonna discuss basics of Maple workflow. So that is the topic, Maple workflow. Our goal is to understand the key concepts and the key tricks that we use every time we work in Maple. Actually, we are not gonna solve any real tasks today yet, but we're gonna learn the alphabet. Yeah, you learn the building blocks of which any Maple workflow is built on. So, actually, let's, as always, list topics that we're gonna cover today. First of all, of course, I'll show you what is what in Maple interface, and it is very intuitive to use, so it's not gonna be very hard. Next, we will discuss Maple working modes. We'll discover there are several of them. These are different regimes in which Maple can operate. Mostly we'll use one of them, but still we need to know what to do if working mode switches. Next, we will have to discuss the command syntax. We need to discuss using variables. As in programming, we will need to store information somewhere. Only now we will not store numbers, we will store formulas. Those would be intermediate steps of our calculations. We will need variables for them. Then we will need to, maybe even before variables, we will need to discuss mathematical notation. How do we write down mathematical expressions, and also maybe standard mathematical functions, because they are very widely used. Those are like sinus, cosinus, sine, cosine, and so on. Then variables, of course, and I forgot something, it seems. Also we will need to discuss the expressions and functions. Those are two ways of representing formulas. And finally, the number formats used in Maple. Maybe we can rearrange that a bit. Maybe we'll cover number formats a bit earlier. Notation functions, maybe here. Like this. So, bunch of topics. Maybe we'll not cover all today, but let's start from Maple interface. For that, I will start my instance of Maple. I have Maple 2017, but Maple 12, a bit earlier version, looks exactly same. Only it has a slightly less colorful and slightly less glossy style. But the layout, all the windows and all the features are same. Okay, so basically that is the starting screen. In version 12, the starting screen may just show you a blank document, but that is not a point. In this version, we can create a new document just from the starting screen, but in earlier versions we can just use file new and actually document mode. Here at once you see there are two things that we can actually create. We can create our our document with this option. Actually, we will mostly use this, but also we can create a worksheet, slightly different thing. But let's start with this one, document mode. So I just close this start window. It will not be needed. Here, what we have in the middle is the work area. Here we will type in commands and get the results. So the basic principle of using Maple is type in a command and get the answer. It is like a dialogue. Okay, for example, I print a command x equal y. Press enter, and my Maple reads this text, parses it, understands its structure, and well tries to answer. But here nothing is actually there is nothing Maple can do with this expression. It can just repeat what we have written. Okay, I'll try another one. Maybe I'll try 1 plus 2. This time Maple is very easy to calculate what we have typed in, and in this case Maple gives us a ready answer. So whenever Maple can evaluate expression, it does. Only when we have just used some unknown variables, Maple of course doesn't have any idea what to do with them. Okay, let's try maybe some more complex expressions, but all in its own time. First of all, you notice, yeah, we are working now in document mode. In it, we type in commands and get results in blue. Whenever Maple can, it evaluates expression for us. In this expression, we can ask to make very complex computations. And also, you may notice that all results that we get, all expressions that Maple gives us, are numbered. They are all have numbers. Thus, numbers can act as references. Later, we can use these results to calculate something from them. Okay. But let's see what else can we do. We can very powerful context menu. For example, we can do a plot of this result. It is a graph, I mean. Very different things. But first of all, I will want to show you the difference between modes. So this is the document. In it, we can use 2D mode for our expressions. So let's have it. First expression in 1D, x by y divided by 3. You may notice that my expression is already built in 2 dimensions, up and up, down, from left to right. I can try to continue it to some more extent. Even I can make some power values. I can make some indexes. I can use many different features here to build this expression as it will look on paper. This is called 2D mode. And basically this 2D mode is default in document. So in this document, Maple document, all formulas will be in 2D. Okay. If you want to use more traditional way of printing formulas like in programming, you can create your document in worksheet mode. That would be actually basic difference. I'll try to do the same. X by Y, brackets, divide by, and you see even here by default in the new versions it is 2D, but you may notice here 2D input. Okay, I can select different option like math, it seems, healing, maple, normal. Okay, here it also applies to the maybe it is okay, let me try to. This is just text. So basically, when you try to print expressions like this, like in programming divided by z, for example, well, you can in some modes, but when you do so, any results Maple produces still will be in 2D. But this 1D mode is outdated. It is not used much anymore. For now, what you do is use document mode. You type in command the same way. You use star for multiplication, you use slash for division, you put brackets as usual. But Maple automatically converts that into 2D formula. So the document mode is default. We will use just it, not to make several versions. So I will skip this session. So to type in such a formula, basically what you do is x multiplied by y, then brackets, or first brackets if you like, slash. Here, if you want everything to be under the division line, you put 3 multiply x divided by t squared, much like you have done it in Maple or in Python. And now, one very important thing to understand. So this one highlighted, it is kind of highlighted in blue. This one is not, because this one is piece of math. You can press enter, and Maple will try to evaluate what you have typed in. In this case, it doesn't know what x, y stand for, but it still can cancel out x and x. You see in the answer there is no x's. Also, it can bring everything into one ratio. Yeah, because there were 3 levels. There remain just 2. The t squared goes to upwards to nominator. Okay. So Maple evaluates everything it can. It tries to simplify it, to transform it in the simplest way it can. But this, here we also have an expression. We press enter and nothing. What's the difference? The difference is the mode. Here we are working in so-called math mode. Everything we type in will be executed. It is like a command for action in a math mode. And also everything is in 2D, because everything will be formulas. Everything Maple does in 2D mode is formulas. When we but we can switch to just text. How to do that? Maybe you have already noticed here. Here is a switch. You see math text here, and the math is active, so we have math. Here text is active, so we have text. I go to the next line and switch back to math. You may notice the cursor has changed. It become inclined cursor. It indicates we have math, and well, just to be sure, it shows you what we're gonna do. I'll just copy the same text. Yeah, I copy it into math mode, press enter, and this time it is parsed and executed. Okay, so here we have text mode, and here the text or math mode is not about the whole line. It is just about a piece we are currently working on. So in the same line I can have a text before my formula. So I have text math mode. Then all the rest is easy to see. All the rest has kind of highlighted, and the math mode is active here. So I try to execute it once more, and again I have text and formula, and I even can have it in the same line. Okay, so in Maple we have two different options of workflow, worksheet and document. Worksheet is outdated. Mostly we will work there with 1D math, which is not very easy to read. So we use document. In it, all formulas are at once typed in as 2D. You build expression as 2D, and mostly it's very easy to do. You can use all the familiar notations for mathematical operators from Python or from Java, if you like. It is automatically transformed into 2D. Only you are working in two different modes here, in text and in math. In text, it is just a text. It will not be executed. In math, it is a mathematical expression which will be evaluated, executed. Okay. Any mathematical expression is executed whenever you press enter in this line. So if I press enter, it is executed again. Let's try it. I will change. It was 3. I update my expression. But you may notice when I do modifications here, the answer doesn't change. It is not evaluated on the fly. It is evaluated whenever I press enter. At any point, enter is evaluated. You see, at this point, my expression changes. Okay, now I can move to another expression here. Again, the same. While I'm editing, nothing changes. Yeah, my expression remains as it was. But when I press enter, you see it's become different. Okay, and it is very important to understand that in Maple, in both modes actually, expression is executed only when we press enter, and the order of executing, the order in which my expressions are executed, is the order in which I press enter. So in here I have my expressions from 1 to 4, but they may not have been executed from up to down. If I press enter here, this is the last one to being executed. This is important when you use a result of one expression in another expression. I can show you now. For example, let me modify this one a bit, x plus y. Here I will use this x plus y. I want to use it, but I want to reference. I want to reference the previous expression. I don't want to rewrite it. Okay, so I evaluate this one, and here instead of just copying same, I will use a reference. I will use this one number. I will have a shortcut for that. Insert the reference for equation 1. Okay, of course it is available in the menu insert, but I will show you the very easy trick to do that. Control plus L, because you will need such references very much. So okay, Control plus L is the reference previous result by number. Okay, so, and there is another shortcut which we will use very much. F5 is the switch between math and text modes. That is exactly what I did to print this text. This text will not be executed when I press enter. I just have a new line. That is text mode. Okay, so here I have a couple of shortcuts for you. Now I have a reference to the first formula. As we already get used to, it is not executed at once. Here we haven't yet seen the difference yet, but we need to press enter for it to be executed. And now we see that really in this expression we have this first one, x plus 1, inside. Okay, so it was substituted by reference. Now let's modify this first expression. I do it x plus y plus z. So the difference will be clearly visible. If I try to press enter, you see there is no z. The first expression is still just x plus y. It was not re-evaluated. So when I execute the second expression, the first expression may not have been executed at all. It all depends on at which point we press enter on each expression. So first we must press enter here. It gets evaluated, and Maple just gives you a hint that it is really evaluated. Now we can execute the second one, and now finally we get here x plus y plus z. That is fine. Okay. So expressions are written in math mode and executed by enter, and the sequence in which they are executed are simply a sequence of pressing enter. Finally, you can reference the previous results by number, and we will learn we can have other kinds of references, but always it is important to keep in mind which expressions you have executed, which you have not. It is not in a natural order, it is in the order of pressing enter. Okay, so that is the most basic thing we have about document mode. Maybe we can write it down. So Maple working modes, just to sum it up. We have a bunch of them. The main mode will work in document mode. It represents all math expressions in 2D, that is in 2 dimensions, like on paper, and it enables to switch between math and text. Math is what will be executed and text not executed. That is the main difference. Executed, and also it can be formatted. I'll show you. Whenever I have text, I have an additional controls active here, and they may resemble controls in Word text editor. They serve the same purpose. For example, I want to use a different kind of font. I can do that. Times New Roman. I will use a different font. I will make this text bold. I will make it italic. I'll make it centered and have a different color. Just have lists, sizes, styles. So I have very powerful tools for formatting. Okay, so the goal of this formatting is to make this document to look like not just a bunch of formulas, like a ready document, like a ready report for your home task or for any assignment you have in your studies. So Maple doesn't just do calculations with formulas. Maple enables you to make a complete document containing mathematical calculations. That is what document mode is about. Okay, so let's see. Represents all math in 2D, that is okay, but document mode is about allows to create documents with rich text content and math calculations. So you can build whole of your report in one application. You don't need Word anymore. The text and math are intertwined in the way you need them to be. Okay, so that is what Maple does. In here, you can have captions. Of course, to have a caption, you need to go to text mode. Maybe have some vertical spacing. You need to have a caption. Basic Maple workflow, and of course, this is too small font for caption, so I make it bigger, I make it bold, and I make it centered. That is fine. What can we have else? Finally, let's look at these two buttons. These are gonna be very, very handy. These are sections. So this is kind of home task 1, a caption for your whole document. But inside you will have different smaller pieces, sections of your document. So basically what I do, I can select all that belongs to one specific task, specific exercise, and press this button to enclose it into a section. A section is shown with such a triangle. I can click on it, and it is, well, shrinks and expands, and also it has its own small caption. So simplest dialogue. That is illustration for simplest dialogue. Then I can have another section with same button. I can call it what do we have next? Working notes, command syntax. Okay, commands. And here I will then do other calculations. Now my document becomes very structured and very easy to work with. Okay, so I go back here. Again, maybe I need to, for this exercise, I need to write some explanation. Here, explanation goes in a text mode, and then math expressions begin. Okay, so in a document mode, what you do is not just calculations. It is a ready document to present your results to anyone. Yeah, it includes text, formatted text, right? In a text mode, it includes sections. That is, they give structure to your document, and also it includes mathematical expressions which are executed in the order of pressing enter. Any questions?
No.
Okay. That is quite intuitive, but well, couple of concepts you need to understand. Yeah. So that is all about basically document mode, and we will give a short reference here to worksheet. Mode is outdated, and we will not use it. It is simpler and for backward compatibility, but we don't need that, so we will not need worksheet mode. So now finally we want to move on. Maybe I will have a couple of reminders for shortcuts we have, or we will have all of them a bit later. Finally, command syntax. That is all tricks that we can use when we enter mathematical commands, not text, right? So, command syntax. Maybe here also we need to note very importantly, we've forgotten, that commands are executed only when enter is pressed on them, and that defines the order of executing commands. That is very important. If you forget that, you will quickly become very confused what is going on. So, command syntax. Basically, our expressions can contain just random math operators, but also it can very often we will call standard commands that basically ask Maple to do something with our expressions, not just stating an expression. Call commands will be very easy. We provide a command name. That would be different. There would be different commands, and here we provide parameters separated with comma, like in programming. So command is much like calling a function in a program. What it does, it takes several expressions as parameters, several math formulas as parameters and can do some transformation on them. For example, for command, let's call a simple command which is solve. This one will solve equations for us. Okay, so this command solve will need parameters which kind of equation to solve. Okay, so here we'll need to put an equation and maybe some other parameters, for example, which variable I need to find, which variable I need to solve for, what is unknown. That is quite good, only this command is not gonna give me anything until it doesn't know what equation is, so we'll have to have a variable. But for now I will just make it with a reference. I put an equation in the previous command, like x squared plus 6x minus 100. I don't know, very complex equation. Maybe not very complex, but still. I need to execute that. I need Maple to actually store the result in its memory. And note, the numbers now are have two levels. Each section has its own numbering. 1, section 2, formula 1. In here, I press Ctrl L for reference and put 1. And this way, I substitute my expression into command as the first parameter. So, press enter, and now Maple knows what to solve, and it gives me the answer calculated by known formula. But if you remember, then Maple can solve in general. Yeah, it doesn't find the numerical solution. It really applies formulas. It really understands that this is a quadratic equation, and he really knows what kind of formula to apply. Even if I modify my equation, still Maple will be very fast providing the answer, but you may be you may suspect that such an answer is very hard to achieve on paper, right? So, okay, just to have it occupy less space, I will get back to quadratic equation. So, but we are not discussing now all the features of equations. We now only understand that Maple has a bunch of standard commands, which what they ask Maple to do something with our equations or with expressions in general, and the expressions we work on are passed as parameters. Okay, that is calling a standard command. Okay, I'll try to make some command which is not a standard command. If Maple doesn't recognize the command, it just repeats. So maybe in some place it is very easy to confuse L with 1. You see, it looks exactly the same, only here I have solve, here I have solve 1v. So, but the result is very different whenever the Maple just repeats what was written. It means it doesn't understand the words that you have written. Something is wrong. Yeah, usual commands almost always give you some output. Solve is sign of some mistyping or maybe wrong command name. Okay, so I'll just store it for you. Wrong command name is easy to guess where it is the case. Now, finally, not all commands are accessible so easily. Many of very useful commands are in packages. Call command from package. There is a default package which is accessible right from start, and solve is in that default package. But you have a bunch of commands in other packages. Then you will need an additional command to kind of import a package, like you have imported a library in Python. Here, with the package name. Okay, maybe I will use some. Maybe I will make what you need to substitute italic, just not to confuse it with standard keywords. With the keyword package's name, you need to substitute. Okay, so for example, there is a very powerful package named plots. It contains functions for doing plots, right? Okay. When I press enter, I really see which functions are imported. You can see it can build animations, it can build 3D plots, it can do many different kinds of plots. Okay, what we can do? We can do, for example, now we can take just one of these functions, this one, which we have just had connected to our project, and here I put some function given in an implicit way. Y squared equals to 5. I don't know which shape it will be, but implicit plot will give us the answer if we do not forget to provide all necessary parameters. Here we see a typical situation: errors. You will get a bunch of them. It says plots implicit plot. It is already means that command was understood by Maple. Now, this command uses second argument, which is missing. Very clear. Yeah, here we need to provide the limits for our variables. We will learn more about this command a bit later, but for now I just provided the necessary limits. And here I have a plot for that function, which is given by implicit equation. This is kind of a complex plotting. It's very hard to do by hand, such kind of plotting. You see, there is no clear correspondence between x and y. You don't have y depending on x. They are all connected to single quotients. That is what makes plotting hard. You can edit this plot, you can rearrange it, change scale, change colors, and so on, change styles. But that is not the point for now. For now, it is that some commands are in packages, and to include those packages, we need to have width. And usually, we will not need the list of functions, so end this command with colon, which means skip the answer. do not print the answer. It is not needed. Okay. Maybe here also I don't need the answer. So with this column, my calculations become more concise. Only if I need to address this equation by number, well, then I need an answer. Yeah? So it means I will need another way referencing these previous results without numbers, and that would be variables. Okay, so we've got back here. We now can call commands. We'll learn different commands a bit later. For now, let's continue and some additional signs. Command separator. Actually, in the document mode, you don't need any command separator, but if you need two commands in the same line, you can use semicolon, like in programming, to separate two different commands. If you have one command per line, you don't need to finish it with semicolon. But to suppress the output, we will use the colon. As you have seen already, it is useful in many cases, makes your document look more concise, more readable. Now, mathematical equation. We already used that. It is just the equal sign. We have already used it in our equation. You see here is equal. In the programming, it was assignment. In Python, for example, equal means assign. Here, it is just an equation. It doesn't assign anything. Basically, it is like in programming, like two equal signs. It just states something is equal to something, not assigning. But we also will have an assignment, and it will be different. That is what we need to remember. A colon equal is assignment. That would be used for variables. Okay, let's have this a bit different. Let's me introduce a variable. I have a name equation. I have an assignment without any spaces, right? It is one word. Colon and equal. And here what to be assigned. And this equal sign is a part of expression. All of this is a single expression. Inside it has equal sign. But assign is different. It divides two pieces. What assigned to what? Okay, so equation. Okay. You see an error. We read it very carefully. Attempting to assign to equation name which is protected. Protected means that is a name used for some standard function or command. Okay, I use different name. Okay, this time it is assigned. Maple just repeats everything was assigned. We don't need such an output. I put colon at the end. But now I can use this EQ name instead of this expression, and can check that it is really same equation that is solved. Very fine. So variables are very, very useful. Whenever I later have at any point later, whenever I have a Q name, it will be evaluated as my equation. I can have it in building more complex things. Oh, okay, what it did. Let's compare what we had. We had left-hand side and right-hand side. So if it is equation, +1 was done to left-hand side separately and to right-hand side separately, because it is an equation, because that is how addition works for equations. Okay, so later I can modify this, make a modified expression, but this doesn't change the variable itself. So any use of this variable will not change it. It still is as it was, but I can have a new assignment, like in programming, right? No, so now EQ variable is assigned this new value, and now it has this new value. And now, very important again to understand, if I return to this solve, it doesn't matter that the solve is upwards. So the direction is not of our document is not important. It is important in which order we really evaluated our statements. This one, for now, it is a solution for old EQ value, for this one. But now I can press enter again. Now the solution is same. Adding 1 to each side doesn't change the solution. We can change that. We can have such modification which will have an effect like this. I applied, check that the equation really now is equal to a new expression, and again solve. Now of course the output changes. It is no longer the solution for this equation. So the results here may be misleading if you forget about the order, in which order really this was executed. If I press enter here and then here, I get one example. If here and then here, I get another result. So everything depends on the order of execution. That is why in your home tasks, really advise you to write down your statements in the order you want them to be executed. So, okay, so that seems like another rule. Yeah, write down math statements. Statements in the order they must be executed. You can do otherwise, but this will make your results confusing. Yeah, no one will be able to understand what is going on, because we do not see the order of execution here. Maple doesn't show us in which order we really pressed enter. Okay, that is important. Maybe a final couple of notions for today. Maybe. Here is a time for some hotkeys. For example, those Ctrl L and F5. Ctrl L is a reference for previous result by number. and F5 is switching between math and text, which is very useful. We have it too. But we have another way of referencing previously the last executed result. Often we need to reference not just any expression. Usually we need to reference the one that was just done before, just previously. In this case we can use another shortcut, quicker one, just %. Okay, so in here in our commands we can have here EQ, but if we are sure this EQ was the last command executed, we can replace it with a %. So % is whatever result was last calculated. So now I press enter here and I really solve this equation. But then okay, I do some other calculations and try to repeat my solution, and this time it does something strange. It tries to solve the graph of our function. Of course it can be done, so the answer is very strange. That is because % is what was last executed, not what is written just above. That is very important to note. We need to write our sentences in their proper order, just to be sure we really mean the previous one, not some other equation somewhere. Okay, that is fine. Okay, the equation is operators. Maybe we'll go through operators for today, and that would be all. So, comparison operators. We have a quotient, but we also have a comparison. They are very easy, like in programming. Less, greater than, less or equal than, greater or equal than, and not equal. Like in Python, only this, not equal. Yeah, in programming you have like this. Maple doesn't understand such notation. Here, not equal is less or greater. That was a comparison operator, and that would be also arithmetical operators. They are also very easy. Multiplication, of course, adding, subtracting, multiplication, division, all of them can be typed from keyboard with usual signs like in programming. Power, like sometimes used in Python, for example. And another one, modulus. Not %, like in programming, because % is used for a different purpose already. So for modulus we will have keyword instead of %. Let's show how to use that. For example, 10 modulus 3. Of course it is 1 because that is the remainder, right? Okay. And remember, when we press star on the keyboard, Maple automatically transforms it into more traditional mathematical sign. When we press slash, it transforms it into division. Okay. And one more thing that I wanted to show you is that these same expressions, same 2D forms for expressions, are also accessible from the panels at the left. If I need division, you can also always insert the ready template and just substitute what you need into it. Okay, for example, if I need a square root, okay, that's very easy. You have plenty of templates here, even for sums, for some standard functions. They are very useful. Okay. And maybe if we have started operators, we should do logical operators. They are not so common in Maple, but still we have not, and, or, XOR, and implies. Remember what it is from discrete math, right? And all of them are words, and they are for logical expressions, but we'll not use them much. And maybe a very, very important one more shortcut I wanted to tell you is a help, because that is what you will need to use very much when you forgot how to use certain command. Control plus F1 is usual help center, and also these usual simpler question mark and then topic can be used to look up help for specific command. Let me show you how to use it. For example, I have forgotten how to use solve, or you don't know how to use solve. Okay, so I put question mark solve, and it opens your help window where it shows you actually documentation for solve with examples. And this documentation is a very good one. So for any command that you forgot, or you have maybe not missed the lecture, I really encourage you to look up here, because this is examples that you can try to copy into your Maple document and actually play with them, and it explains a lot. It has an explanation. Okay, and also in this help it has not only the search, but also when you press Ctrl F1, it gives you a full index of what we have in the help system. It's very, very, very wide. It has many different topics, but the one I want you to start with is here, tutorials. Really, they will be really helpful. Of course, I will tell everything you need in lectures, but also I really encourage you to look here. And for this first lecture, please read this first one, Talking to Maple. This is kind of a Maple document. Each tutorial is a Maple document, in which you have ready commands that you can execute by yourself. You can modify and play with them, and it has explanation. It really leads you step by step to understanding how to get started with your Maple tasks. It explains you the forms of mathematical input, how to reduce different kinds of outputs, how to use the panels of Maple. So the very topics I have told you just now, I want you to also read this first tutorial to make sure you really grasp these basics. And I put this in your first task. Here it is. Install Maple, that we have already started to do, and go through the first tutorial. Here is the link to the same tutorial on the web. The same, absolutely same page is also available on the web, but in reality it is better to open it up in help system. Let me show you again. Control F1. F1 and getting started tutorials, talking to Maple. Because here it is interactive. It is just a document where you can play with. Okay. No set changes. And also when you did something for your home tasks, do not forget that this document is like a Word document. You need to save it. Here you have buttons. Here you have a menu to save, and also of course Control S. Save, and maybe downloads is not a good place, but I'll do it. It'll do for now. I give it a name. One basic workflow. It's not the end, so it will be 1 basic workflow. And note this file, this worksheet will be saved as MW file, which stands for Maple Worksheet. Save. Let's see where we get it. Here it is. It is saved in my drive directory I selected, and later, tomorrow, I can close Maple application. I can now double click my worksheet file, and Maple will start with it. Wow, that is all for today. Any questions for this basic workflow, for basic commands that we had? When I hope it is understood, what you now really need to do is try to play with these simple tricks once you have a tutorial. That is your task for the next week. And do not forget about presentation that remains from the previous week, right? That is all. Of course, I will put the notes, and also I will put the this document we've done into Drive, as always, and I put the recording on YouTube.
Okay, perfect. Kirill.
Okay, so for the next week, one more time, I need you all to do home task 1. That is important.